recorded. So the session is being recorded. As I said in the beginning, this is EP session for the final exam of Maths 002, organized by the Arshfete channel. So we go through the material from section 2.8 until chapter 12, inshallah. So let us begin with questions from chapter, I think this is a combination of chapter 4 as well as 2.8 because of the inverse. Now here the question says, if f is given to us, then the domain of the f inverse is what? Now this question, we can solve it in about 3 ways. One way is by solving it directly. Find the inverse and then find the domain of the inverse. Another way is to find the range of the function, because we know that the range of the function is equal to the domain of the inverse of the function. And the other way also, we could graph it. By graphing, easily we can find the domain of the exponential function and its range as well. So now the choice is ours. So let us take a look at maybe just 2 methods, okay? 2 methods will be fine. Now I will show you the, let's say method 1. Now for the first method, what I'm going to do, I'm going to find the inverse, but of course we do not need to find the inverse, all right? I will find the inverse and give you the domain. Then we use the concept of the inverse of function to answer the method 2. So by the first method, we have y equal to 1 plus e to the power of x minus 1. Now what we do now is to find the inverse of this function. So by finding the inverse, we interchange x with y. So y shall be changed to x plus 1 plus e to the power of y minus 1. Now take 1 to the other side, we have x minus 1 to be equal to e to the power of y minus 1. Now to be able to bring the y minus 1 down, we are going to take the ln of both sides, natural logarithm of both sides. So therefore here, we are going to have y minus 1 to be equal to ln of x minus 1. And here we can solve, taking 1 to the other side, so we can say y is equal to 1 plus ln of x minus 1. Now, if I don't want to write y, I can replace this y with the f inverse. So we can say here, the f inverse of x is given to us as 1 plus the ln of x minus 1. Now, what is the domain here? The domain of ln, we say the argument should be greater than 0. So we say here, x minus 1 is greater than 0. And what does it mean? It means x is greater than 1, which means we have from 1 to infinity. So this is getting the domain by method number 1. Now, what is other method? The other method is much easier than this one. So let us call it, for example, method 2. By the method 2, we are given the exponential function. Now, the exponential function, we are going to find the domain. So by method 2, we know that the domain of f inverse is going to be equal to the range for the function f. This we know. Now, we are going to find the range of f. What is the range of e to the power of x? We know that the range of e to the power of x, please pay attention. When we say e to the power of x, let me write it properly, e to the power of x, the range shall be always greater than 1. So it is going to be from 1 to infinity. Now, what if we shift it horizontally? Horizontally, we mean we have x minus 1. So this horizontal shifting does not affect our range. The horizontal shifting is only going to affect the domain. It has nothing to do with the range. So the range will still be greater than 1. I'm writing wrongly. Here it is the beginning. This is e to the power of x. So e to the power of x is greater than 0. Sorry. Okay, so when we shift it horizontally, it will still be greater than 0 without any problem at all. Now, what is the next thing to do? We go back. We have here plus 1. So we are going to add 1 to both sides. So let us add 1 here. So we can say 1 plus e to the power of x minus 1. Here we say greater than. Then we say greater than as before, greater than 0. But we added 1 on the left side. So we are going to add 1 on the right side. So you can see that here, it means f of x is going to be greater than 1. Now, this is our range. So you can see that the range of f is going to be equal to the domain. So the domain is going to be 1 to infinity. That is going to be equal to the domain of the f inverse. So whichever we follow, we get the same answer. You can also use the concept of the graph here. Is there any question here, please? So you can see here the right answer, obviously, it is A. Okay, now, if there is no question, or maybe you are reserving a question till the end, let us proceed with the second question. Now here, what do we have? It says, from a point on the ground, okay, 100 root of 3 feet from the base of a building. So we have a building, and then we have, okay, let me just make a rough sketch. Let's have a rough sketch. So let's say this is our building, for instance. Here is our building. Okay, my picture may not be accurate, but just something to manage up. So here, let us make it beautiful. So let's say this is our building. Now we know, the question says, from a point on the ground that is to the building, the base of the building is 100 root of 3 feet. This we have. Now, it says an observer find the angle of elevation to the top of the building to be 30 degrees. So here, the observer is here from this point. So it says 30 degrees. So the angle of elevation, that is the angle for looking up. Here we have it to be 30 degrees. Then what else further? What else further? Here it says, and that the angle of elevation to the top of a flagpole on top of the building is A. So there is a flagpole on top of the building. So let us get a flagpole. So we have a flagpole on top of this building. Okay, so we have the flag here. Now, it says further, the angle of elevation to the flagpole is alpha. So let us draw another line. So we are talking about the same point. But here should be noted, when we say the angle of elevation, that is going to be now this big angle. It is formed with the horizontal line, and this is what we call the alpha. Now, what is the question saying? And we are given the tangent of alpha is given to us. The question says find the length of the pole. So here, for simplicity, we can take a look at two triangles. I mean, let us take a look at this triangle. Okay, the one that I painted yellow. Let us take this triangle out first. So here we have a triangle. Now here we have 30 degrees. Here we have 100 root of 3. Now the height of the building, how tall is the building? We don't know. So let me call this one HB. That means the height of the building. Now we can say, of course, this is going to be 90 degrees. So we can say H at the height of the building over the adjacent. 100 root of 3 is going to be equal to opposite over the adjacent is going to be equal to the tangent of 30 degrees. Now, we know what is tangent of 30 degrees. The tangent of 30 degrees is going to be 1 over square root of 3. So therefore, what does it mean? It means the height of the building is going to be equal to, when we multiply, we say 100 root of 3 divided by 3 root of 3, and the answer will be equal to 100 feet. So the height of the building is 100 feet because the root of 3 goes with the root of 3. Now we are done with the first triangle. Now let us take a look at the bigger triangle now, which is actually the bigger picture. So let's bring it out, please, for simplicity and understanding. Now the angle, the bigger angle is alpha. Now here we have two things. The height of the flagpole, so let's say from here to here is now the flagpole. So here we can say the height of the flagpole, the HF. And here we have the height of the building. So you will agree with me that the total height, which we are talking about here, we can record this one, the total height, okay? But instead of that one, we can say addition, which is going to be much easier. So what do? Again, we have opposite over the adjacent. So here, the opposite is going to be H, the length of the flagpole, plus the height of the building, divided by 100 root of 3, because the bottom line, the bottom side is the same and is common to both triangles. Now this is going to be equal to the tangent of alpha. Now we have good news. The good news is that the question gives us the tangent of alpha. So here, what do? I'm going to substitute the tangent of alpha. So here we have HF plus the HB to be equal to 100. Let me write it separately. This is equal to 100 root of 3 multiplied by the tangent of alpha, which is going to be 21, divided by 20 root of 3. Now you will agree with me that the root of 3 will go to root of 3, 20 can go into 100, and that will be 5 times. So here, this is going to be equal to 5 multiplied by 21, and that is going to be 105 feet. So now we are looking for the height of the flagpole. So let us observe this. So we can see clearly that the height of the flagpole plus the height of the building is equal to 105 feet. Now already we know the height of the building. So that means the height of the flagpole will be equal to 105 minus 100, which is going to be equal to 5 feet. So the length of the flagpole is equal to 5 feet. Is there any question here? Or it is clear? Okay, now, if there is no question, we proceed. Now, this is a question that is coming from 5.3 in combination with section 6.2. Here, the question says, if we are given U to be equal to sine of 780, we are also given V to be equal to the whole of this one. Now, the question says, what is going to be this expression? So here, what do we do? Now, as a general guideline, whenever we are given angles, any angle we have, for simplicity, we always try to convert them to an angle between 0 and 90 degrees, always. So how do we do that? Now, let me get started with V, for instance. For the case of V, we have this is going to be equal to, now we can say this is an odd function, or you can just find the coterminal directly. So if I call it odd function, I can take the minus outside, then this is going to be minus cotangent of 950 degrees plus tangent of 220 in degrees. Now, let us find the coterminal angle. Here, we have the angle that is greater than 360 degrees. So remember, when we go around the circle one time, complete revolution, it is 360 degrees. If we go 2 times, it's going to be 720 degrees. If we go 3 times, it's 1080 degrees, and continuously. So what do we do now? To find the coterminal angle, we say 950 degrees minus 720 degrees. This is going to be 0.3, and this is going to be 230 degrees. So we can rewrite this one to be equal to minus cotangent of 230 degrees plus this is not changing, tangent of 220 degrees. Now we have this. What do we do next? Now we need to know which quadrant we are dealing with, because that is the most important aspect here. So if you look at this one, 230 degrees, that tells me that we are in quadrant number 3. Also observe that 220 degrees, we are in quadrant number 3 as well. So here we have quadrant number 3, and here we also have quadrant number 3. Now in quadrant number 3, we know that the cotangent is positive in quadrant number 3. In quadrant number 3, tangent is also positive in quadrant number 3. So that means the two sides will not change, it will remain the same. So here we can say this is going to be equal to minus the cotangent. Now what is the reference angle? That is going to be 50 degrees. How do we get 50 degrees? We say 230 degrees minus 180 degrees, which is going to give us 50 degrees. And then plus, here we have the tangent. Again, the reference angle, this is 220, so this is going to be 40 degrees. We have tangent of 40 degrees. Now we have good news, because the angles now are between 0 and 90 degrees, so we can play the game we want to. Now, if you look at it, the angle of 50 degrees is not famous, neither the angle of 40 degrees is not famous. But we know from the co-function identity, what do we know? We know that tangent of theta is equal to cotangent of h 90 degree minus the theta. In other words, what am I trying to say? I'm saying that the tangent of 40 degrees is equal to cotangent of 90 degrees minus 40 degrees, which is going to be equal to cotangent of 50 degrees. They are cofunction. So if I write this one, this shall be equal to minus the cotangent of 50 degrees. I am not touching this one. Now plus, we have cotangent of 50 degrees again. Why? Because tangent of 40 is equal to cotangent of 50. Now you can see here, this and this we cancel out, and the result is going to be equal to 0. So this means here the V is going to be equal to 0. Now, we are done with V. Let us find now U. What is our U? U is equal to sine of 780 degrees. Now, again, if you look at it very carefully, you see that the angle is greater than 780 degrees is akbar 360 degree. So what do? We are going to find the coterminal angle again. If we go around the circle one time, that is 360. 2 times 720 degrees. 3 times 1080 degree. But the angle is not up to 1080. So we are going to subtract 720. So here we have 780 degrees minus 720 degrees, and this is going to give us 50. Is it 50? That is going to give us, gentlemen, 60 degree. 8 minus 20 minus 2. So this is going to be equal to sine of 60 degree. Now, sine of 60 degree is in quarter number 1. And in quarter number 1, we know that it's going to be positive. So sine of 60 degree is going to be equal to square root of 3 over 2. This we know. So we have the U and we have the V. Now let us go back to the question. The question wants us to find 4 into U squared plus V. And this will be equal to 4, okay, into, we know V is 0, but U squared, what is our U? U is root of 3 over 2 all squared. Because V is 0, so there is no need to waste time on that one. And this is going to give us 4 into 3 over 4 when we square. And then we can say that 4, we go with 4, and our final result is going to be equal to 3. And that is our beautiful answer. Is there any question here, please? Maybe something is not clear to you, or something is of concern. All right. Okay, let's continue. Here in exercise 4, the question tells us that if we have secant of x plus cosecant of x, divide by tangent of x plus cotangent of x is equal to a sine of x plus b cosine of x. Now the question says, what is going to be a plus b? Now we can answer this question in a couple of ways. But one easy way that always comes to the mind, the fact that we have sine and cosine here, it will be good to convert everything to sine and cosine to make life easy. Another way is to multiply the denominator by the conjugate of the denominator. But of course, converting to sine and cosine will be much easier for us. So let's do that. Now, secant, let us convert it. We are going to get 1 over cosine, 1 over cosine of x. Cosecant, we have plus 1 over sine of x. And then we have tangent, everything divided by tangent. The tangent is going to give us sine of x over cosine of x. Then we have cotangent, that is sine of x, divided by cosine of x. Now, this shall be equal to what? For the numerator, we are going to take the LCD. The LCD is going to be sine of x multiplied by the cosine of x. So now, when we cross this one here, what do we get? We are going to get sine of x plus. Then we cross these with this one here. We have plus cosine of x. We do the same thing to the denominator. Now for the denominator, again, the LCD is sine of x multiplied by the cosine of x. So cross multiply, we have this. So here we have, I think I was writing something wrong here. If you look at it, cotangent. Cotangent is cosine of x, of course, over sine of x. I was repeating tangent. So here now, when we cross the multiply, you see, now this is going to be sine squared, and this is going to be cosine squared. So in the here, numerator of the denominator, we have sine squared of x plus cosine squared of x. Now we have good news. Okay, the denominator for the numerator, we cancel the denominator for the denominator. So now also we have good news here. We know that sine squared plus cosine squared is going to be equal to 1. So this is going to be equal to 1. So that means we are going to get the result to be equal to sine of x plus cosine of x divided by 1. Of course, it's not going to change anything. Now, if we compare this, our result, with the question itself, then you will agree with me. We can say, therefore, our a should be equal to 1, and also our b should be equal to 1. Now, the question is asking for a plus b. So, therefore, a plus b shall be equal to 2, which is our answer. So another way you can do, so you can see that changing everything to sine and cosine, it always guarantees you to get the answer, although you may spend more time in getting the answer, but it always guarantees you. So another way to solve this question, or to give it a try, is to multiply both numerator and denominator by the conjugate of denominator. Okay, so that means I'm going to multiply by tangent of x minus the cotangent of x. That should give you also the same answer. Any question, please? All right. So here we continue with exercise 5. What does the question say? It says if the function, we are given the function, is written in this form, okay, then what is going to be k, b, and c? Now, this is the reduction identity. Now, by reduction identity, we need to be able to write in this form. But when we write in this form a reduction identity, we need to know what is k. So what form is that? Let me write it directly in reduction identity. We are supposed to rewrite it as y to be equal to k, then sine. Now we have this one, I have x, I have x. They must always be the same before we can use the reduction identity. If the two angles are not the same, then reduction identity cannot be used. So since they are the same, we have 1 over 2x directly. Then we need something which is very important, plus alpha, which we don't know. Now we have a vertical translation, and this is the vertical translation. The vertical translation, ordinarily we are supposed to say plus c, but instead of saying plus c, since the question already gave me the vertical translation, I can write it directly, 11 over 2. Now when you make the comparison of this one with this, you will agree that we are going to be looking for k. This is going to be representing our b. Of course, this one is already alpha, and this is representing our c. So you can see we have good news. We already know what is b, and we already know what is c directly from the question. So what I need to find here only is k. And what is k here? It says k is given by the square root of a squared plus b squared. Now what is a? Which one is a? Which one is b? We call this one here a. The coefficient of sine is the a, whereby the coefficient of cosine is always the b, always true. Now when you check some old exam question, be very careful. There is a possibility that they can write it like this one, maybe, let's say 2 cosine of 3x plus, let's say 3 or 3 over 2 sine of 3x. Now here we have to be very careful. This is a, and this one is going to be the b. So a is always the coefficient of sine, and b is always going to be the coefficient of cosine. Take note of that. So this is going to be equal to, now we have the a squared, that is going to be 1 over 2 all squared, plus the b squared, and that is going to be minus root of 3 over 2 all squared. Now when we simplify this one, what do we get? We have root of 1 over 4 plus 3 over 4, which is going to be root of 4 over 4, right? And then that is going to be 1. Root of 1 is going to be equal to 1. So our k is equal to 1. Then we have good news. We know a, we know b, we know k. So therefore, answering the question, we have k plus b plus c. That will be equal to 1 plus b. Our b is 1 over 2, and plus c, that is 11 over 2. Now, when we add them together, this is going to be equal to 1. 1 plus 11, that is 12. 12 divided by 2 is going to be 6. Plus this, and then the result is going to be equal to 7. So this is our answer. So this is how to use the reduction identity. Now observe here that the question did not ask us to find the alpha in this question. Sometimes we may come across a similar question in which we also need to find the alpha. Now to find the alpha, you can use the method the book uses in 7.2 is different from what is used from chapter 9. That is the vectors. You can use the idea of the vector. What is that one? You can say the tangent of alpha is equal to b over a. And already you know what is b according to the question. The b is minus root of 3 over 2 divided by 1 over 2. So you can see this we cancel with this one, and then you see that the tangent of alpha is equal to minus root of 3. Now, I need to know which quadrant we are dealing with. Now, how do I know the quadrant we are dealing with? We have a to be positive. We have 1 over 2 and b minus root of 3 over 2. Now, that tells us that we are saying positive and negative. Positive, negative means that we are in quadrant number positive, negative. We are in quadrant number 4. So now the famous angle is going to be root of 3, which is going to be 60 degrees. Then 60 degree in quadrant number 4, that means alpha is going to be equal to 300 degrees. Although the question did not ask us to find alpha, but I'm just telling you quickly as a revision to remember how to find alpha in case we need it. Questions, please. Okay, now we have equation here. The question says the equation of cosine of x, cosine 3x, sine x, sine 3x. We have a good news because we know that this one is a property. Cosine, cosine, and sine, sine. That is a property. Of course, it is a property for the difference of the angle for the case of cosine. So we can say this is going to be cosine of x minus the first one, and then this side will change to minus by the second one, 3x. And this is equal to 1/2. So you can see the beauty aspect of this. Now simplifying, we get here cosine of minus 2x to be equal to 1/2. We know cosine is an even function, so we can throw away the minus. So we can write it as cosine of 2x to be equal to 1/2. Now we can see that we have this one to be positive. Cosine is positive only in quadrant number 1 or in quadrant number 4. So we are going to find the answers in 2 quadrants. So let us get started. In quadrant number 1, what should be our answer? Double. So here we have 2x to be equal to, now the famous angle that gives us sine to be equal to a half, that is going to be, cosine to be equal to a half, that is going to be equal to 60 degree. So that is pi, 60 degree, we can write it as pi over 3, or you can say 60 degree. Now, because the angle here is double, now I am going to add here the coterminal angle so that we are going to find the general solution, 2n pi. Now, why am I doing this? Because we have a multiple angle. So what do we do now? Let us solve for x. What is going to be x? Therefore, x will be equal to, divide by 2. We have pi over 6 plus n pi. And this is the general solution. This is our general solution. That is in quadrant number 1. How about quadrant number 4? In quadrant number 4, again, we have the angle, which is going to be 2x, to be equal to, now in quadrant number 4, what do? We say 2 pi minus pi over 3, and that is going to give us 5 pi over 3. Then to find the general solution, we say plus 2n pi, because we have, again, a multiple angle. So let us divide it by 2. So we have x to be equal to 5 pi over 6 plus n pi. Gentlemen, this one here and this one here, we call them the general solution. We call them the general solution. Let me create a space. Now, we want to find the specific or the exact solution that is in the interval. Which interval is that one? The interval of minus pi to 0. So now, what do? Okay, I can use a test value. The test value, for instance, I can start when n is equal to minus 1. I cannot say, when I say n equal to 0, for example, if n is equal to 0, we are going to get the first one is going to be x equal to pi over 6, and the next one is going to be 5 pi over 6. But this is not in the interval. Which interval is that? The interval of minus pi to 0. So now, I'm going to use n equal to -1. So if I substitute n equal to -1 here, we say pi over 6 minus pi, and that is going to give us x to be equal to minus 5 pi over 6. The second one, if we put n to be equal to -1, we have 5 pi over 6 minus pi, and that is going to give us minus pi over 6. So you can see that we have two solutions in this interval. So here we can say this means the solution set is going to be equal to minus 5 pi over 6 and minus pi over 6. And this is our beautiful answer. So you can see that here the number of the solution is 2. The number of solution for this equation is 2. Questions, please. Okay, now, if there is no question, let us proceed. Here, it says, let U be a vector of magnitude 2 and direction 120 degrees. V to be a vector A common square root of 3. Now, if U and V are orthogonal vectors, then what is A? A is equal to what? Now, before we talk about the orthogonal vectors, let us define clearly our vector U. What is vector U? The vector U is equal to, generally to find a vector, let's say U is supposed to be equal to the magnitude of U multiplied by the cosine of the angle that is given theta, then the magnitude of the vector U again multiplied by the sine of theta. That is a rule, right? So let us try this one out. We are given the magnitude of the vector U, and the magnitude is 2, multiplied by the cosine of the theta. The angle is 120 degrees. Then we have 2, now sine of 120 degrees. Now we have good news. 120 degrees is in quarter number 2. In quarter number 2, cosine is negative. Now quarter number 2 also here, but sine will be positive. So let us rewrite. So U shall be equal to, now we have minus 2 cosine. What is the reference angle of 120 degrees? That is 60 degrees. Common 2 sine of 60 degrees. Now simplify further. What is this? This will be equal to minus 2. Now what is cosine of 60 degrees? That is going to be 1 over 2. Now we have common 2 sine of 60 degrees. Sine of 60 degrees is root of 3 divided by 2. Here is what we have. Simplify by cancelling. This we go with this, and this we go with this one. So what do we have? This is going to be equal to minus 1 and then root of 3. So we have the vector U. We have the vector U. Now, vector V is directly given to me. I know the vector V is given. Now, the question tells me that the two vectors are orthogonal. So let us write vector U and vector V are orthogonal. That means they are perpendicular. They are orthogonal if and only if, that means the two ways, the dot product of U and vector V is equal to 0. The dot product is going to be equal to 0. So therefore, what do we have? We have the vector U that is going to be minus 1 root of 3 multiplied by the vector V, A root of 3, and this should be equal to 0. Now let's do the multiplication. We get minus a plus root of 3 multiplied by root of 3. That is going to be 3 is equal to 0. And that means a shall be equal to 3. And that is what the question is asking us to find. It says a is equal to what? The value of a. And that is our answer. Questions, please. Okay. Now let us look at number 8. The question says the number of solutions of the system of nonlinear equations is what? Now we have nonlinear system of equation because you consider this is not linear. Also, the second equation is not linear. But for simplicity, let's call this one equation number 1, and let us call this one equation number 2. Now we can say from equation number 1, what do we have? We can say this one here. No, let us use equation number 2 is better. From equation number 2. So taking the equation number 2, we can say that absolute value of y, or x is equal to absolute value of y. X is going to be equal to absolute value of y. Now what am I going to do? I am going to substitute this one in equation number 1 now. So we can say substitute. Let's call this one equation number 3. Substitute equation number 3 into equation number 1. Of course, I cannot substitute into 2 because 2 and 3 are the same. We only write them differently. So therefore, what do we get? We are going to have here 2x squared. So we are going to have 2x is going to be the absolute value of y. Then square this one. Plus, it is minus y squared equal to 4. Now let us simplify this one. If we simplify, what do we get? We are going to get 2y squared minus y squared to be equal to 4. Why did we say this? We know that the absolute value of y squared is going to be equal to absolute value of y squared, which we can write as y squared. Because of the absolute value, the power here can always remove the negative sign, so there is no need for the absolute value any longer. So here now, when we simplify, we are going to get y squared to be equal to 4. So if y squared is equal to 4, then what do we get? If y squared is equal to 4, then what do we get? It means we are going to say y is equal to plus or minus 2. So we have 2 possible values for y. Now, if I have 2 possible values for y, what is going to be the value of x? What is going to be the value of x? So here, let us substitute. We say substitute for y. We can use either of the equation, but in equation number 3, it will be much easier. So here we have, when we have y to be equal to, for example, 2, then we say x is going to be equal to absolute value of 2, which is equal to 2. And that means we have a point. X is equal to 2, y equal to 2. Now the second point, we have y to be equal to minus 2. Then x is going to be equal to absolute value of minus 2, which is going to be equal to 2. And that means we have the second point. X is going to be equal to 2, y is minus 2. So if you look at it very carefully, we see that we have 2 solutions. If I want to write the solution set, so we say therefore, the solution set will be equal to 2 common minus 2, the set of ordered pair, then 2 and 2. So here you can see that we have 2 solutions. So care must be taken. You cannot say because you are saying the 4 values, we have 4 solutions. That will be wrong. We have only 2 solutions. Questions, please. Okay. We go to example number 9. Here the question says the linear system whose augmented matrix is this one has what? Now, how do we approach this question? I should be thinking of rewriting it in echelon form using the Gauss-Jordan method of elimination. If I'm able to write it in echelon form, and we know that whether we are having unique solution, that means one solution, or we have no solution, that means inconsistent system, or we have infinitely many solutions, dependent system. Now, what do I do? So you can see here, the first one, it's okay, so I'm not going to touch the first row. That is good for me. Why? Because it starts with 1, which is what we are looking for. Now, what do we do next? We need this guy to be equal to 0, and this guy should be made equal to 0. Then this one, I should make it 1. This one should be made 0. This one should be made 1. That is our target. How do I do that? Now, to make this one to be equal to 0, I would say minus 2. I want to have space. Minus 2, row number 1 plus row number 2. So we are going to touch row number 2 only. Row number 1 we are not touching. So here we have 1, minus 3, 4, and then we have 1. Okay, now next one. We multiply now row number 1 by negative 2. Pay attention. If we multiply by negative 2, I'll get here minus 2. Multiply by negative 2, we get 6. Multiply by negative 2, I get minus 8. Multiply by negative 2, I get minus 2. Then what do? We add this one and this one together. Add this one and this one together. Add this and this one together. Add this and this one together. If I do that one, then what do we get? Minus 2 and 2 gives us 0. 6 minus 5, that gives us 1. Minus 8 plus 3, that is giving us minus 5. Then minus 2 and 6, and that is giving us 4. Now, the first one, it's okay. Now, let us go to the second step. Now, what to do next? We target to make this one to be 0, this one to be 0. And how do I make the first one to be 0? Now, we are going to multiply the row number 1 by minus 1. So minus 1 multiplied by row number 1 and add it to row number 3 to get the result. So let me shift this one up a little bit. Okay, now, so let us multiply by minus 1. So here will be minus 1, here will be 3, here will be minus 4, and here is minus 1. Then add this and this together, add this and this together, add this and this together, and add this and this together. So when we add then, we are going to get minus 1 and 1 is going to be 0. Then we have 3 minus 2, that is going to be 1. Minus 4 minus 1, that is going to be minus 5. Then minus 1 plus 5, and that is going to be 4. Now, if you look at this one very carefully, I don't know if you see what I'm seeing, but you can see that here, the row number 2 and row number 3 are exactly the same. Row number 2 and row number 3 are exactly the same. Now, if you remember, if the two rows are the same, then that means we have dependent system. That means we have dependent system. Dependent system means we have infinitely many solutions. Infinitely many solutions. Now, can I say here that the solution set is equal to from minus infinity to infinity? No, we cannot. The solution set is not minus infinity to infinity. Writing the solution set for dependent system has a special form, which we can take a look at if we have time at the end of the day. But this, we conclude that we have, you see, when you look at this linear system, we are talking about 3 lines, right? So you can see clearly that these 2 lines, they are exactly on top of each other. So that means the third one also will be on top of this one, and that is why we said we have infinitely many solutions. Is there any question here, please? Okay, no question. So let us proceed. Here the question says, given the matrix, the value of M, 1, 2. Recently, in the old exam, they tried to give us the name to avoid confusion. So here you say M12, that is called the minor, of course. We call it minor. And then this C23, we call it cofactor. Cofactor. Now, both minor and cofactor, they are determinant of matrices obtained by deleting the ith row and the jth column. What am I saying? If I have Mij, now if I want to find this one here, this is representing the determinant of a matrix after we delete the ith row and the jth column. What do I mean? Let's take it. Let's go to the equation directly. Now, for instance, here we want to find the M1, 2. What is that? This is going to be equal to the determinant of the matrix. So we are going to put the same matrix. We have 2, 3, 2. Then we have 3, 4, 1. Then we have 4, 0, and 1. So what do? I am going to delete here. The row is 1. I'm going to delete row number 1. Okay, delete row number 1. And then column number 2 should be deleted also. We are going to delete column number 2. Okay, now. So this one, we can say the minor of the element 3, but because we have more than 2, 3 in the element of the matrix, we cannot say that. So what is this one equal to? We are going to get a beautiful 2 by 2 matrix. So this is going to be equal to 3, 2, 0, 1. Now, we know what is this one, right? Find the determinant for 2 by 2. This is going to be cross multiply. We say 3 multiplied by 1 minus 2 multiplied by 0, right? And what is this one equal to? This is going to be equal to 3. So we have M12 to be equal to 3. Now, the next one, we say C to 3. Now, what is C to 3? By definition, this will be equal to minus 1 to the power. You add the script together, 2 plus 3, and that is going to give us 5. Multiply by the minor of 2, 3. Now, when we simplify this one here, this is going to be equal to minus m to 3. So this is going to be equal to the minus outside. Again, we have a 3 by 3 matrix, the determinant for 3 by 3. So here we have 2, 3, and 2. We have here 3, 4, 1. Then we have 4, 0, and 1. So we are going to delete here row number 2 and a column number 3. So this question is the same as finding the cofactor of the element 0. Find the cofactor of element 0. So here now, this is going to be equal to, again, minus. We have 2 by 2. 2, 2, 3, and 1. So now, what do we get? This is going to be equal to, we have minus outside. So 2 multiplied by 1, that is going to be 2. Minus 3 multiplied by 2, that is going to be equal to 6, which is going to be equal to minus 4. And then the result is going to be equal to 4. So now, what does the question say? Therefore, we are looking for m 1, 2, which already we know, plus 2 multiplied by c to 3. And this is going to be equal to 3 plus 2 into 8. No, 2 into 4, sorry. And this is going to be 3 plus 8, which will be equal to 11 as our answer. So we must not forget, most often, students made confusion between the minor and the cofactor. The minor is just deleting the ith row and jth column directly. You delete the ith row and the jth column directly. If I have 3 by 3 matrix, for example, A, B, C, D, E, F, G, H, I. Now you can delete row number, let's say maybe 2, row number 2, and let's say column number 3 directly. Now, what of the cofactor? The cofactor is a minor. Here, the cofactor is defined, ij is equal to minus 1 to the power of I plus j, then mij. So if I plus j is even, the cofactor is equal to the minor. If I plus j is odd, the cofactor is equal to minus the minor. You should always keep this at the back of the mind and never to forget it. Questions, please. All right. Now let us proceed to 11. What does the question say in 11? Here the question says the equation of the parabola. So that means we are in chapter 12 now. Parabola with vertex. We have good news. The question gives us the vertex. The vertex here we have H, and here we have K. The vertex of the parabola. We denote it as H and K. Then we have the focus of the parabola given to us. Now let us look at it very carefully. You will agree with me that the horizontal components are the same. Minus 5, there is no change. But when you look at this one, we have minus 6 and minus 5, there is a change. What does that mean? It means that we have a vertical parabola. Vertical parabola, because there is a change in y. There is a change in y, so it is vertical parabola. Now, if I know this is vertical parabola, then life is easy because the question gives us the focus. Now, what is the focus? According to the question, the focus is minus 5 and minus 5. Now, since we are talking about the vertical, since we say this is vertical, then I can say this is equivalent to, okay, when we are looking for the focus, it should be H, and then we have P plus K. Remember that we have good news because we know H and K. So what does that mean? We already know that h is equal to -5. So that means what? That means k should be equal, p plus k should be equal to also -5. So therefore, p plus k is equal to -5. Now, good news is that we know what is k, so we can say p minus 6, which is k, is equal to -5, and that means p shall be equal to 6 minus 5, and that is going to be equal to 1. So p is equal to 1. Now, the question is asking for the equation of the parabola. Now, what is the standard equation of the parabola or vertical parabola? Because it is vertical, so I can write it as the equation x minus h all squared to be equal to 4p bracket open, we have y minus k. Now let us substitute h and k, and then we know p already. So if we substitute h and k, we have x minus h, that is going to be minus 5, and that is going to be plus 5 all squared, equal to 4, because p is equal to 1, so we say 4 into 1, bracket open, we have y minus 6 plus 6. Now simplify, open the bracket. If we open this bracket, we are going to get x squared plus 10x plus 25. That is the left-hand side. And then the right-hand side will be equal to, now 4y plus 6 multiplied by 4, and that is going to be 24. Now let us bring the 4y to this side and also bring the 24 to the other side. So we have x squared plus 10x. Then we have minus, when we bring this y here, we have minus 4y. Then here we have 25 minus 24, and that is going to be plus 1 equal to 0. And that should be our equation that we are looking for. So if you look at it carefully, you will agree that the answer, of course, is A. So when we come to select the answer, we have to be extremely careful. Careful in the sense that we do not make mistake in the sign when we are making the selection. Do we have any question here, please? Okay. No question. Let us proceed here to the last question. Here it says the asymptote with positive slope of the hyperbola. The asymptote with the positive slope of the hyperbola is what? So we are given the hyperbola. Of course, it is very clear that the center is not at origin, because we can see here negative 2x and negative 100y. So let us try to rewrite, please. In rewriting, I would say here we have x squared, then minus 2x, collecting the like terms together. Then for the case of y, we get minus 25 y squared, then minus 100 y, and then on the other side, we can say this is equal to 124. Now, what we do next is to complete the square in x and then in y. If we do the completing the square in x, we get here x squared minus 2x. Observe that to make the completing the square, we add 1 for x. Now, for the case of y, we can take minus 25 as a common factor outside. If I take minus 25 as a common factor, then I will be left with y squared minus, no, it is going to change to plus now, right? Plus 4y. This is what we have. But if we do completing the square here, this is going to be plus 4. Close it, and then this is equal to 124. Now, we have added here 1. So we add 1 on the left side, we add 1 also on the right side. Now we have added 4, but 4 we multiply by minus 25, and that is going to give us minus 100. Okay, now let us write it in a beautiful form by factoring. We have x minus 1 all squared, a perfect square trinomial. Then here we have minus 25 outside. Then factor, we have y plus 2 all squared. Then we have 125 minus 100, and this is going to be equal to 25. Of course, we can write it as 5 squared, but we are not interested in that. Now, to write it in standard form, what I will do now, I need to divide, because the right answer should be 1. So divide by 25. I will divide each of them by 25. Divide by 25. And also here, divide by 25. So now, if we rewrite, we're going to get x minus 1 all squared over 25 minus, we have y plus 2 all squared, because this we cancel with this one. Okay, let me put it in the center. So we have it as y plus 2 all squared, and this will be equal to 1. This is what we have. Now, if you look at it carefully, you will see that the part with x is positive, and that tells me that we have horizontal. We have horizontal hyperbola. Because the part with the positive is x. Now, what do we know? What do we do? The question wants me to find the positive asymptote. Now, what is the asymptote for the horizontal parabola? The asymptote for the horizontal parabola, it is going to be y minus k equal to plus or minus b over a. So if it is vertical, we say OA over b. Horizontal is b over a. So we say x minus h. Now we need to know a. We need to know what is b. Now observe very well, clearly, that from here we know that a squared is equal to 25. And that means a shall be equal to 5. Now the second part, we also know that b squared should be equal to 1. B squared is equal to 1, and that means b shall be equal to 1. Now here, if I substitute, remember that we are looking for the positive slope, so I don't need plus or minus. I need to put only the positive slope, the one that is positive, based on what the question is asking. So therefore, we have y, what is going to be our k? We say y plus 2. It is y plus 2 is clear from the question directly. It's equal to, the b is 1, and the a is equal to 5. 1 over 5 into x minus 1. Now, let us clear the fraction. If we clear the fraction, we are going to get 5y plus 10 shall be equal to x minus 1. Now, the answer is putting everything together. So bring everything to the left side. So we have 5y. Now, minus x, minus 1 comes here, is going to be plus 11, which is going to be equal to 0. And that is the equation of the asymptote with the positive slope. Remember, the question did not ask for the negative slope. But if we check for the negative slope, maybe there is going to be an answer. For instance, let us try and see. If it is negative slope, we have y plus 2 equal to minus 1 over 5 into x minus 1. Now multiply through by 5. So we have 5y plus 10, which is going to be minus x minus 1. Open the bracket. We have 5y plus 10 is equal to x plus 1. Minus x plus 1. Bring x here. We have x plus 5y. And then bring this one here, plus 9 equal to 0. So here, the good thing is that the answer is not in the multiple choice. Otherwise, we will have to be very careful. So this is the good news here. So this is the equation with of the asymptote with negative slope. For the positive slope is what we find. So this marks the end of our EP session today. Now, if you have questions on any part that is not clear to you, you can raise up your hand to ask the question while I make available the solution for you in the Microsoft team, so that if you want to make reference to it at any time, you can do that. Remember, this EP session is coordinated by Arshifة channel. Okay, we thank the guys for the organization always. Yes, questions, please. You can ask question also from any part of the material, not necessarily from the questions that I have given. Any part of the material. Okay, let me try to see now if everything is okay. Okay, so that I post you the question and the solution. Okay, let me go to the channel. Okay, the step-by-step solution we discussed today is uploaded. I wish you all the best in your exam. In the absence of any question, we're going to call it a day. Assalamu alaikum.